we're looking at transformations of y equals 1 over x. So we do need to know what y equals 1 over x looks like. But if you don't know, you can just graph it on your calculator. It looks like this. It has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. And it's these two lines. So it's in two parts. What would you say the domain of that function is? So domain x such that x is an element of the set of real numbers, but x cannot equal 0. That sounds good. It's everything but 0 where that asymptote is here. And so then what's the range? Same thing but with y's, right? So the range is y such that y is an element of a set of real numbers. Y cannot equal 0. What would that domain look like if we did it in interval notation?
Negative infinity to infinity.
Lower limit is negative infinity. So we're going to start with that. But then how far do we go before there's a break in the graph? 0. So negative infinity to 0 and 0 to infinity. You could put a U in between for a union, right? Some of you are using that notation, or just a comma is fine. But it goes from negative infinity to 0, but doesn't reach 0. That's why I have that round bracket. And then it goes from just after 0, that's why I have the round bracket again, to infinity. But the question wasn't about the domain and range. The question is to compare the function, which is here, y equals 4 over x, to y equals 1 over x by identifying any stretches or translations, then draw the graph. So how does y equals 4 over x compare to y equals 1 over x? What's the transformation? What is it? Yeah, what kind of stretch? Horizontal or vertical? Vertical stretch. By a factor of 4. Because it's a vertical stretch. So we may want to think about, is this really in transformational form, y equals 4 over x? Not exactly. But that's the same as this, y equals 4 times 1 over x. And then it's kind of easier to see that that is a vertical stretch by a factor of 4 because it's outside of the 1 over x function. And it's the same thing, right? Because this would just be 4 times 1 over x, so 4 over x. So if the stretch is in the numerator, it's actually a vertical stretch, but you can pull it out like that and see the vertical stretch there. So y equals 4 times 1 over x. So then if we were going to try to graph it, a mapping rule would be xy maps to x and 4y. And then we could look at some actual points. So there's a point at 1, 1 here. Where would that translate to, or transform to, I should say? Sorry? 1, 4? Yeah, it's the y that's changing, right? So 1, 4. Oops. So 1, 4 is there. That dot's a little big, isn't it? Make the other one smaller. So the point -1, -1 would transform to -1, -4. Now that dot's kind of small, but down there. And then we need to look at a few other points. And it's a little tricky to actually look at the points here, right, on 1 over x. But let's say, here we have a point of 2 and 1/2. Where would that go? 2 and 1/2. That would go to 2 and 2, yep. Two and 2, so that's going there. And then 3 and 1/3. Or let's do 4 and 1/4. Where would that one go? 4 and 1. So you can kind of see the shape of the graph starting here. It's going to look very similar, but it kind of comes like that. And through, oops, I slipped there. See if I can erase that. Yep, try again. It's going to come through more like that. So I want to show you another question. It's this. Compare the function to y equals 1/x by identifying any stretches or translations, then draw the graph. I may not try to draw this graph. It didn't go so well in the last one, but we'll at least come up with a mapping rule. What transformations do you see happening here in this one? Y equals 2/x minus 3 plus 2. So we could rewrite that. Y equals 2 and then in brackets 1/x minus 3 plus 2. So I just took the 2 outside of the fraction there. What are the transformations that are happening? Vertical stretch by a factor of 2. Vertical stretch by a factor of 2. What else? Horizontal translation. How many units? 3 units to the right? Yep, because it's x minus 3, so it's moving 3 units to the right. And then what about that plus 2 at the end? Vertical translation. 2 units up. I guess I'll do the mapping rule. The mapping rule would be x, y maps to x plus 3 and then 2y plus 2. The 1/over part is already built in because of what the parent function is. Parent function is 1/x. This one's a little bit trickier though, because it's harder to find the transformations. We need to take this function, which is here on the right, y equals 1/2x minus, 1 minus 2x over x, and change it into this transformational form, y equals a times 1/x minus h plus k. And then talk about the transformations. So this is the part of it that's new for you. All the transformation stuff we've already learned. But taking a function like that, y equals 1 minus 2x over x, and changing it into transformational form is new. What we're actually going to do here is split that, that fraction. And I'm going to change it into y equals 1/x minus 2x over x. Does that seem okay, what I did there?
Yes.
Yeah, I can't split a denominator, but I can split a numerator. And so I can make it 2 fractions with the same thing. Now if we try to simplify one of them, which one of those will simplify? 2x over x. What does it become? 2. So this is actually just y equals 1 over x minus 2. And now you can say what the transformations are. There's actually only one. And what is it? The minus 2. So it's a vertical translation 2 units down.
Well, the 2 is with the x, so it's not really a translation. It's both a reflection and a threat.
And here's another one of those which is actually a little bit trickier. Y equals 33 minus 6x over x minus 5. If we just split it like we did in the last question, we're going to have 33 over x minus 5 minus 6 over x minus 5, and neither of those will simplify. What do we need to have happening in the numerator and the denominator to be able to simplify? We had it in the last one. We had 2x over x. So we had a common factor in the numerator and denominator. We need that here as well, but we need to figure out how we're going to get a common denominator. And the common denominator has to be x minus 5 because that's the only factor in the denominator. So I somehow need to get an x minus 5 somewhere in the numerator. And this is how I'm going to do it. Does anyone have an idea? Yes? I'm not going to tell you then. I'm going to listen to what you have to say. Here's what's going to happen. I'm going to change the 33 into 3 plus 30. Is that still equal to what I started with? Yeah, so it's okay to do that. And now I'm going to change this again. And I'm just going to change it to negative 6x plus 30. Which is still the same, right? I just switched the order around. Now I'm going to split it. I'll make this one a 3 over x minus 5. And this one a negative 6x plus 30 over x minus 5. And the reason that I split it that way is because the one on the right there, negative 6x plus 30 over x minus 5, actually now has a common denominator in the numerator and the denominator. But you probably can't see it yet. Well, maybe you can see it.
I can kind of see it.
You can kind of see it?
Minus 6 times x minus 5 is equal to that.
So what I'll do with this one on the right is factor out a negative 6 in the numerator, and I get x minus 5. And there's the common denominator, the x minus 5 in the top and the bottom. So now I can simplify it finally to y equals 3 over x minus 5 minus 6 when I take out that common factor. And from there, I can say what the transformations are. Now we can see that there's a vertical stretch by a factor of 3. There's a horizontal translation, 5 units to the right, and a vertical translation, 6 units down. And then we could make the new graph from that.